For generations, Betelgeuse has been one of the most recognizable and fascinating stars in the night sky. Located in the constellation Orion, this enormous red supergiant has attracted astronomers because of its tremendous size, intense brightness, and dramatic changes in appearance. Massive stars live very different lives from stars like our Sun. They consume their nuclear fuel at an extraordinary rate, producing enormous amounts of energy during relatively short lifetimes. Betelgeuse is believed to be in a late stage of stellar evolution, making it an especially important object for scientists studying how massive stars change before the final stages of their lives. The star became the center of worldwide attention in late 2019 and early 2020, when its brightness dropped dramatically. Betelgeuse normally appears as one of the brightest stars in Orion, so the sudden fading was impossible for astronomers to ignore. Almost immediately, one possibility captured the public imagination. Could Betelgeuse be preparing to explode? A supernova involving such a nearby massive star would be one of the most spectacular astronomical events humanity could witness. But astronomers continued observing the star instead of jumping to conclusions. Eventually, evidence suggested that the dramatic dimming was most likely connected to material released from the star itself. A huge amount of gas and dust moved into the region between Betelgeuse and Earth, temporarily blocking some of the star's visible light. The explanation was less catastrophic than an imminent supernova, but it revealed something equally fascinating. Betelgeuse is an incredibly active star. Its surface is not a perfectly smooth sphere. Instead, enormous regions of hot plasma move through its outer layers. Massive convection currents transport energy from deeper inside the star toward the surface. Some regions become brighter and hotter while others cool and change the star's appearance. The result is a giant stellar atmosphere that is constantly shifting. This is one reason Betelgeuse is so valuable to astronomers. It provides a nearby laboratory for studying the behavior of massive stars. The arrival of the James Webb Space Telescope opened another opportunity to investigate objects like Betelgeuse. Webb's infrared capabilities allow astronomers to observe details that can be difficult to detect in visible light, particularly when dust and gas are involved. Infrared observations can reveal the distribution of material surrounding a star and help researchers understand how massive stars lose material over time. Around Betelgeuse, enormous amounts of gas and dust have been expelled into space. Each layer of material carries information about events that occurred on or near the stellar surface. By studying this material, astronomers can learn more about the powerful processes occurring inside the star. And those processes are important because massive stars eventually return much of their material to space. Inside their cores, nuclear reactions create heavier elements from lighter ones. Over the course of a massive star's life, increasingly complex elements can be produced. When such stars eventually reach their final stages, some of that material can be released into the surrounding environment. That material can later become part of new stars, planets, and other cosmic structures. So Betelgeuse is more than a bright red point in Orion. It is a window into the life and death of massive stars. Its changing brightness, turbulent surface, and surrounding material allow scientists to observe processes that are difficult to study elsewhere. And the possibility of a future supernova makes the star even more intriguing. But when will it happen? That is a question astronomers cannot answer precisely. Betelgeuse could continue changing for a very long time before reaching its final explosion. Or, on astronomical timescales, its transformation could occur relatively soon. What scientists do know is that the star provides an extraordinary opportunity to study stellar evolution. And every new observation brings researchers closer to understanding what happens when one of the universe's most powerful stars reaches the end of its remarkable life. The story of Betelgeuse is not simply the story of one enormous star. It is also a story about how the universe creates, transforms, and recycles matter. Massive stars are among the most powerful factories in the cosmos. Deep inside their cores, extreme temperatures and pressures allow nuclear reactions to transform lighter elements into heavier ones. Over millions of years, these processes change the composition and structure of the star. Eventually, a massive star reaches a point where it can no longer maintain the same balance that has supported it throughout its life. Before that final stage, however, the star can undergo enormous changes. Betelgeuse provides scientists with an opportunity to observe some of these processes while the star is still visible from Earth. Its enormous surface is constantly moving. Hot material rises from deeper layers, releases energy, cools, and sinks again. These convection processes can create enormous variations across the stellar surface. At the same time, the star can release material into surrounding space. Gas and dust gradually build up around it, creating an extended environment that can be studied with infrared observations. This is particularly valuable because visible light does not reveal everything. Dust can obscure important details, while infrared radiation can provide information about cooler materials surrounding the star. That makes instruments such as the James Webb Space Telescope extremely useful for studying the complex environments around evolved stars. The more scientists observe Betelgeuse, the clearer it becomes that the final stages of massive star evolution are not simple. A giant star does not necessarily move smoothly from one stage to another. It can experience periods of instability, changes in brightness, powerful outbursts, and the gradual loss of material. These events help scientists refine models describing how massive stars evolve. Eventually, Betelgeuse is expected to end its life in a spectacular way. If it undergoes a supernova, enormous amounts of energy and material could be released into space. Astronomers would have an extraordinary opportunity to observe the process in detail. They could study how the explosion develops, how matter is expelled, and how the remnants of the star interact with their surroundings. A supernova would also help scientists understand how heavy elements are distributed throughout the galaxy. Those elements do not simply disappear after a star dies. They can become part of future generations of stars and planets. In that sense, the death of one massive star can contribute to the birth of something new. This is one of the most remarkable cycles in astronomy. Stars form from material left behind by earlier generations of stars. They live, transform their internal material, and eventually return enriched matter to space. That material can later become part of new cosmic systems. And some of the elements essential to planets and life ultimately come from these ancient stellar processes. When we look at Betelgeuse, therefore, we are not simply observing a distant object. We are observing a stage in the enormous cycle that has shaped the universe for billions of years. The oxygen around us, the carbon within living organisms, and many of the elements found on Earth have cosmic histories that stretch back to stars that existed long before our solar system formed. Betelgeuse reminds us that the night sky is not static. Stars may appear motionless from Earth, but they are constantly evolving. Their surfaces move. Their brightness changes. They release material. And eventually, the most massive among them reach spectacular conclusions. Whether Betelgeuse explodes relatively soon or continues its evolution for thousands or even longer, it will remain an extraordinary target for astronomical research. Every observation gives scientists another piece of the puzzle. And powerful observatories like Webb allow humanity to examine that puzzle in greater detail than ever before. The real mystery is not simply when Betelgeuse will explode. It is how much more this enormous star can teach us before that final moment arrives. Because when we study the life of a giant star, we are also studying the history of the elements that eventually became worlds, oceans, atmospheres, and life itself. Betelgeuse may be millions of times farther away than anything humans could ever reach. Yet its story is connected to ours. We are, in a very real cosmic sense, made from the history of stars.